So now, before we come to the Coriolis force, I just want to show you how the dynamical structure of the oceans looks like. It's actually, there is most regions of the ocean are controlled by the geostrophic balance. Okay, and this balance we will explain and discuss later in this lecture. Okay, it's a balance between pressure gradient forces and the Coriolis force. No friction, almost no friction in the ocean interior, and friction is confined to boundary layers. And we talk about surface, a surface boundary layer known as the surface Ekman layer. And if the current extends to the seafloor, there's also a friction with the seafloor, known as the bottom Ekman layer. And in addition to that, you can also have a friction with coasts, horizontal, lateral friction, we call it. Okay. So this is the structure. This is the general structure. No friction or little friction in the ocean interior. The frictional effects are actually confined to Ekman layers. Okay, next slide. So what do you get if you just have a frictional force along the surface? All right, so you have a wind stress. Okay, a wind that blows along the surface for a very long time, no other forces. And that's what we do in oceanography. We just imagine that we only have one force. Okay, that's what we do in fluid dynamics. And this is shown here in a little sketch. So you look at looking from the side, you have a frictional stress characterized by this arrow, has a certain direction, blows along the surface. And what you get in the end is something that we call a vertical shear flow. Okay, a flow that is horizontal, but it's strongest near the surface. And then the speed linearly decreases with depth and goes to zero near the floor. Okay, so this is what we call a shear flow, and you get that without rotational effects, which means without the Coriolis force, you get these type of flows. And the balance that you get in the end, it's a balance between frictional, it's a purely frictional feature, this shear flow, is known as, it's actually the definition of something we call dynamic viscosity. Okay, it's a feature of the fluid that you're dealing with. Okay, and that is the shear that you get, or the essentially the surface speed that you get of the current is determined by the frictional stress, so how strong the wind is, and the dynamic viscosity plays a role with it. Okay? In rotating fluids like the oceans, the Coriolis force influences the structure of these flows. But however, it's good to know about these vertical shear flows because there are a principal generator of something we call turbulence in the ocean. So you need a shear flow in order to create a perturbations, mixing in the ocean. It's always linked to these vertical shear flows. Okay, they can create turbulence.